$1.4 trillion. That's how much economic value GPS has generated for the United States alone. It runs your phone, your flights, your financial markets, and a device that costs less than a pair of sneakers can fake the signal behind all of it. The pilots won't know. The stock exchanges won't know. Your Uber driver definitely won't know. Here's what we're going to cover. How GPS actually works, because it's not what most people think. Why it's so easy to attack. What's already happening in the skies right now. And why no one has fixed it. Most people assume GPS works both ways. Your phone talks to satellites, satellites talk back. It doesn't. GPS is entirely passive. Your phone never sends anything to any satellite. It just listens. 31 satellites orbit at 20,200 kilometers. Each one carries atomic clocks synchronized to billionths of a second, broadcasting the time continuously. Your phone picks up 4 or more of those signals, measures the differences in arrival time, and works out where you are. Each satellite transmits about 25 to 50 watts of power, roughly a light bulb. After traveling 20,000 kilometers, that signal arrives at your phone at about 10 to the negative 16 watts. Weaker than the minimum signal for a phone call. Weak enough that a device in your backpack could overpower it. And the civilian signal, the one your phone, your plane, and your bank all use, is unencrypted. The code is public. There are 2 ways to attack GPS. Jamming is the blunt version. You blast noise on the same frequency, drown out the real signal. The receiver loses GPS, but it knows it lost GPS. Like someone shouting over you in a conversation. Crude. Obvious. Spoofing is different. A spoofing device sends fake GPS signals, slightly stronger than the real ones. The receiver locks on, calculates a position, and shows it on screen. The wrong position, and nobody knows. 10 years ago, a spoofer cost around $100,000. Today, an SDR board for about $150 and some open source code. With a board like that, your range is typically a few hundred meters. Military systems cover entire regions. And this isn't theoretical. Right now, the largest GPS warfare experiment in history is playing out over Ukraine. Russia jams and spoofs drone navigation on a massive scale. But radio signals don't stop at borders, and they can't tell a drone from an airliner. In early 2024, about 300 flights a day were getting hit with spoofed GPS data. By August, that number was 1,500, a 500% increase in 6 months. On Christmas Day 2024, Azerbaijan Airlines Flight 8243 lost GPS navigation entering Russian airspace near Grozny, where military electronic warfare was active. The plane was then hit, likely by Russian air defense fire, and crashed near Aktau, Kazakhstan. 38 of 67 people on board died. On the battlefield, both sides are already working around the problem. Fiber optic drones, FPV drones on thin fiber cables, 5 to 20 kilometers long. Light signals instead of radio. Immune to jamming. About $800 each. But you can't run a fiber cable from a 737 to the ground. For commercial aviation, the problem is still open. And it goes way beyond aviation. GPS isn't just about where you are. It's about when. Stock exchanges use GPS discipline clocks to timestamp every trade down to microseconds. Power grids depend on GPS timing for synchronization. Telecom networks, logistics, all built on the same signal. That NIST study that produced the 1.4 trillion figure, it also estimated that a GPS outage would cost about $1 billion a day. During planting season, the total damage could reach $45 billion. By early 2026, nearly 100% of long-haul flights between Europe and the East were encountering GPS interference. Finnair suspended flights to Tartu, Estonia, because repeated GPS outages made landings impossible. NATO airspace, not a conflict zone. The answer goes back 50 years. GPS was designed in the 1970s for military use, with encrypted signals for authorized users. The civilian version was left open, unprotected, by design. And then the world built everything on top of it. Defenses exist: military encryption, integrity monitoring, multi-constellation receivers. But none of them fully solve the problem at civilian scale. The only US program to build a GPS backup constellation, Resilient GPS, was shelved in January 2026. Congress added $15 million. But no satellites are funded. GPS didn't fail. We just forgot it was never designed for the world we built on top of it. Engineering decisions from decades ago still shape the systems we depend on. That's what this channel covers. If that's interesting to you, hit subscribe. Thanks for watching.